Hello everyone and welcome to Learn at the Rate 10. Today we are going to solve some word problems in linear equations in two variables. To do this, we have to form equations from the given conditions in the word problems and then solve the equations by any method to get the answers of our two variables. If you haven't watched my videos on different methods on solving linear equations in two variables, I would advise you to do so before moving on with this video. Generally, there are 5 different types of questions. The first one involves perimeter, area and volume questions. The second one is generally on finding numbers. Third one is on speed, distance and time. Another one is on cost price and selling price. The last one is on ages on people. Now let's start with our first example. My first question is on perimeter, volume and area. The question reads, the perimeter of a rectangle is 40 cm. The length of the rectangle is more than double than its breadth by 2. Find length and breadth. Now the question states two distinct conditions. The first condition being that the perimeter of rectangle is 40 cm and the second condition being that the length of the rectangle is more than double its breadth by 2. Now let's try and solve this problem. First, we will assume what is asked in the question. So let's take the length of the rectangle be x centimeter and breadth of the rectangle be y centimeter. Therefore, by first condition, which I said previously that the perimeter of rectangle is 40. The formula for perimeter of rectangle is 2 into length plus breadth. Therefore, 2 into length plus breadth is equal to 40. Therefore, 2 into x plus y is equal to 40, since x and y represent length and breadth here respectively. Therefore, x plus y is equal to 20 is my equation number 1. By second condition, which is length is more than double its breadth by 2, I get x is equal to 2y plus 2. Here, please notice that my x is length, which is 2 times the breadth plus 2, meaning it is 2 times the breadth and it is more than 2 times the breadth by 2, which gives me x minus 2y is equal to 2. This is my equation number 2. Since coefficients of my variable x is same and the signs are similar, I will subtract equation 2 from equation 1. Remember, while subtracting, keep the equation with a greater constant on top line and the equation with a lesser constant in the second line. Therefore, x plus y is equal to 20 minus x minus 2y is equal to 2. Subtracting causes a change in sign in the coefficients of my second line, which makes x minus 2y as plus and 2 as minus. This gives me 3y is equal to 18. Therefore, y is equal to 6. Now substituting this value of y is equal to 6 in equation number 1, I get x plus y is equal to 20. This is my equation number 1. Therefore, x plus 6 is equal to 20, which gives me x is equal to 20 minus 6. Therefore, x is equal to 14. Therefore, the length of the rectangle is 14 cm and its breadth is 6 cm. Now let's move on to our next question, which is on sums on digits of a number. The question reads that a 3-digit number is equal to 17 times the sum of its digits. If the digits are reversed, the new number is 198 more than the old number. The sum of extreme digits is less than middle number by unity. Find original number. Now before solving, you might be wondering that a 3-digit number would require 3 variables. However, we have a condition mentioned in the question which states the middle number in terms of its extreme digits. It says that the middle number is more than the sum of its extreme digits by 1. Therefore, we will be assuming the extreme digits as x and y. Let's take the digit at hundreds place to be x, which gives us 100x, and the digit at units to be y. Therefore, the middle number becomes x plus y plus 1. Now since the middle number is at tens place, we have to multiply x plus y plus 1 the whole into 10. Therefore, the 3-digit number is 100x plus 10 into x plus y plus 1 plus y. This gives me 100x plus 10x plus 10y plus 10 plus y. Solving this equation, I get 100x plus 11y plus 10. The second condition states that the sum of its digits. Now let's take sum of its digits, which will be x plus into brackets x plus y plus 1 plus y. Therefore, solving this, I get 2x plus 2y plus 1. Therefore, by first condition, I get given number is 17 times the sum of its digits. Therefore, 110x plus 11y plus 10 is equal to 17 into 2x plus 2y plus 1. Solving this, I get 110x plus 11y plus 10 is equal to 34x plus 34y plus 17. Therefore, I will be regrouping the x variables together and the y variables together, and I will be sending the constants on the other side of the is equal to sign. Doing so, I get 110x minus 34x plus 11y minus 34y is equal to 17 minus 10. Therefore, 76x minus 23y is equal to 7. This becomes my equation number 1. Now, reversing the digits in the original number, we will get 110y plus 11x plus 10. This is really simple because we just have to change the place of x and y in my first condition. Therefore, by second condition, I get that the original number plus 198 gives me the new number. The original number was 110x plus 11y plus 10. I have to add 198 to get the new number, which is 110y plus 11x plus 10. Therefore, this gives me 110x minus 11x plus 11y minus 110y is equal to 10 minus 10 minus 198. This gives me 99x minus 99y is equal to minus 198. Dividing throughout by 99, I get x minus y is equal to 2. And I can write this in terms of x. Therefore, x is equal to y minus 2, which is my equation number 2. Substituting y is equal to x minus 2 in equation 1, I get 76 into y minus 2 is equal to 23y minus 7. Please note here that I'm using elimination by substitution method. In the previous sum, I used elimination by equating the coefficients. You can use determinants or even graphical method to solve the word problems. It completely depends upon you and with which method you are comfortable. Therefore, solving ahead, I get 76y minus 152 minus 23y is equal to 7, which gives me 53y is equal to 7 plus 152. This gives me 159 is equal to 53y. Solving this, I get y is equal to 3. Now substituting the value of y is equal to 3 in equation 2nd, I get x is equal to 3 minus 2. Therefore, x is equal to 1. Since the digit at hundreds place was x and the digit at units place was y, I have my answer of units and hundreds place. Therefore, the digit at hundreds place is 1 and the digit at units place is 3. Let's find out the middle number. As per the condition, the middle number is 1 more than the sum of the extreme digits, which gives me 3 plus 1 plus 1 is equal to 5. Therefore, the number is 153. Now let's take a sum on speed, distance and time. The question reads that a boat travels 16 kilometers upstream and 24 kilometers downstream in 6 hours. The same boat travels 36 kilometers upstream and 48 kilometers downstream in 13 hours. What is the speed of the boat and of the water current? Now we have to calculate the speed of the boat in still waters and the speed of the water current. Therefore, this should be our x and y. Let's assume the speed of the boat in still water be x kilometers per hour and the speed of the water current be y kilometer per hour. Therefore, while the boat is moving downstream, the speed of the current will add up to its speed, which will give us x plus y kilometers per hour. When the boat is traveling upstream, the speed of the water current will be opposite and therefore will reduce its speed. Therefore, the speed of the boat upstream will be x minus y kilometers per hour. Now we know that distance is equal to speed into time. In this equation, we have assumed the speed at which the boat and the water current is traveling. Therefore, we will change the formula in such a way that we get time is equal to distance upon speed. Therefore, from first condition I get 16 upon x minus y plus 24 upon x plus y is equal to 6. Please understand that 16 and 24 are from the kilometers the boat has travelled in upstream and downstream respectively, and I will be dividing it with my assumed speed in x and y. Therefore, the speed in upstream will be x minus y and the speed in downstream will be x plus y. Therefore, from first condition I get 16 upon x minus y plus 24 upon x plus y is equal to 6. Now you might be wondering, where did I get this fraction? The fraction comes from the formula that time is equal to distance upon speed. Now let's move on to second condition, which is 36 upon x minus y, which is 36 kilometers in upstream, plus 48 upon x plus y, which is 48 kilometers downstream, is equal to 13, which represents 13 hours taken by the boat. Now you might have noticed that the equations here are in fractions form and the denominators are our variables. We have learned in previous double substitution method that we have to replace this fraction form to form a general equation of ax plus by is equal to c. Therefore, I will be replacing my 1 upon variables with another variable. Replacing 1 upon x minus y with a and 1 upon x plus y with b, we get 16a plus 24b is equal to 6. This is my equation number 3. And 36a plus 48b is equal to 13. This is my equation number 4. I can equate any of the two coefficients of my variables, and I choose to do so with coefficients of b. Therefore, multiplying equation 3 by 2, we get 32a plus 48b is equal to 12, which is my equation number 5. Now, I will be solving equation 4 and 5. Since the coefficient of b has same sign, I will be subtracting one equation from the other. And as you might know that we have to subtract the equation with lesser constant from the equation which has a greater constant. Therefore, subtracting equation 5 from equation 4, we get 36a plus 48b is equal to 13 minus 32a plus 48b is equal to 12. Subtracting causes change in sign and I get 32 in minus, 48 in minus and 12 in minus. This gives me 4a is equal to 1. Therefore, a is equal to 1 upon 4. Substituting this value of a in equation 3, I get 16 into 1 upon 4 plus 24b is equal to 6. This gives me 4 plus 24b is equal to 6. Therefore 24b is equal to 6 minus 4. Therefore the value of b is equal to 2 upon 24 or 1 upon 12. Now we have derived the values of our variables a and b, but we have to derive the values of x and y. Therefore we will be resubstituting the value of a and b in form of 1 upon x minus y and 1 upon x plus y. Therefore 1 upon 4 is equal to 1 upon x minus y and 1 upon 12 is equal to 1 upon x plus y. Therefore x minus y is equal to 4 is my equation number 6 and x plus y is equal to 12 is my equation number 7. Now I will be solving these two equations as an independent problem. Now since the coefficient of my variable y is same but in different sign, I will be adding equation 6 and 7. Therefore 2x is equal to 16. Therefore x is equal to 8. Substituting the value of x is equal to 8 in equation 7, I get y is equal to 12 minus 8 is equal to 4. Therefore, the answer is the speed of the boat in still water is 8 km per hour and the speed of the water current is 4 km per hour. Let's take another sum on speed, distance and time. The question reads, out of 1900 km, we shall travel some distance by bus and some by airplane. Bus travels at an average speed of 60 km per hour and airplane travels at an average speed of 700 km per hour. It takes 5 hours to complete the journey. Find the distance travelled by Vishal by bus. Now I have to find the distance travelled by Vishal only by bus. Therefore, let the distance travelled by bus be x km and by airplane be y km. Therefore, from first condition we get that x plus y is equal to 1900, which is the total distance that Vishal has travelled. Since time is equal to distance upon speed, therefore time required to cover some kilometer, which is x, by bus would be x upon 60. 60 is the average speed of the bus, and time required to cover y km by airplane will be y upon 700. 700 being the average speed of airplane. Therefore the whole journey was 5 hours, which gives me from second condition x upon 60 plus y upon 700 is equal to 500 is equal to 5. Therefore 700x plus 60y upon 60 into 700 is equal to 5. Sending 60 into 700 on the other side of the equal to sign, I get 70x plus 6y is equal to 5x 5 into 60 into 700. Therefore 70x plus 6y is equal to 2100. This is my equation number 2. Now multiplying equation 1 by 6, because I am equating the coefficients of y, I get 6x plus 6y is equal to 11,400, which is equation number 3. Subtracting equation 3 from equation 2, we get 70x plus 6y is equal to 21,000 minus 6x plus 6y is equal to 11,400. Subtracting causes change in sign and 6x becomes minus 6x plus 6y becomes minus 6y and 11,400 becomes minus 11,400. This gives me 64x is equal to 9,600. Therefore x is equal to 9,600 divided by 64. Therefore x is equal to 150. Therefore the answer is that Vishal travelled 150 kilometers by bus out of 1900 kilometers that he travelled totally. Let's take another sum on speed, distance and time. I'm focusing on these type of sums because they are very different from one another. Other type of sums which are similar will be in the description. Please do not forget to check the description so as to find similar type of problems and solve them with particular methods as I've shown in this video. The question reads that places A and B are 30 kilometers apart and they are on a straight road. Hamid travels from A to B on bike. At the same time, Joseph starts from B on bike and travels towards A. They meet each other after 20 minutes. If Joseph would have started from B at the same time but would have travelled in opposite direction, Hamid would have caught him after 3 hours. Find the speed of Hamid and Joseph. Now, the question is asking us to find the speed travelled by Hamid and by Joseph on their bikes. Therefore, let the speed of Hamid be x km per hour and speed of Joseph be y kilometers per hour. Therefore, they covered 30 kilometers in just 20 minutes. Now 20 minutes has to be converted into hours, or 3 hours has to be converted into minutes. Here, for ease, I'm converting 20 minutes into hours, which gives me 1/3 hour. Therefore, distance covered by Hamid is 1/3x kilometers. Since in an hour he can cover x kilometer, therefore in 1/3 of an hour he will cover 1/3 of the kilometer, which is 1/3 1/3x. At the same time, distance covered by Joseph is 1/3 the distance he can cover in 1 hour. Therefore, the distance covered by Joseph is 1/3 of y kilometers. By first condition, I get 1/3x plus 1/3y is equal to 30. You might have noticed that the equation is not in the general form of ax plus by is equal to c. Therefore, I will be multiplying throughout by 3 to get the general form. This gives me x plus y is equal to 90. This becomes my equation number 1. Now, let's move on with the question. In 3 hours, Hamid would travel 3 times its speed, which is 3x kilometers, and Joseph would travel 3 times his speed, which is 3y kilometers. But Hamid's 3x kilometers will contain the 30 kilometer that he's previously traveled in the first condition. Therefore, by condition 2, I get that 3x minus 3y, which is the distance travelled by Hamid minus distance travelled by Joseph in opposite direction, the difference will give me a distance of 30 kilometers. Therefore, I get 3x minus 3y is equal to 30. Dividing throughout by 3, which is common in the equation, I get x minus y is equal to 10. This becomes my equation number 2. Adding 1 and 2, since the coefficient of y is same but with different signs, I get x plus y is equal to 90 plus x minus y is equal to 10. Adding causes elimination of variable y, and I get 2x is equal to 100. Therefore, x is equal to 50. Substituting x is equal to 50 in equation 1, we get 50 plus y is equal to 90. Therefore, y is equal to 90 minus 50, which is 40. Therefore, the speed of Hamid was 50 kilometers per hour and the speed of Joseph was 40 kilometers per hour. Now let's move on to a different type of sum. This is sum on ages of people. The question reads that the sum of father's age and son's age is 70. If we double the age of father and add it to son's age, we get 95. Find their present ages. Now, since the question is asking ages of father and his son, we will be taking the age of father as x years and age of son be y years. Therefore, by condition 1, which is the sum of father's and sun's age is 70, I get x plus y is equal to 70. And this becomes my equation number 1. The second condition is that we have to double the father's age, which will become 2x, and then add it to son's age, which is y, to get 95. Therefore, 2x plus y is equal to 95 is my equation number 2. Now since the coefficients of equations, the coefficient of y is same, I will subtract equation 1 from equation 2, which gives me 2x plus y is equal to 95 minus x plus y is equal to 70. This gives me x is equal to 45. Substituting x is equal to 45 in equation 1, I get 45 plus y is equal to 70. Therefore, y is equal to 70 minus 45, which is y is equal to 25. Therefore, the answer is that the father's present age is 45 years and the son's present age is 25 years. Let's take another type of sum. This is sums on cost price and selling price. The question reads, selling 11 analog watches and 6 digital watches gets a total of rupees 4,330, and selling 22 analog and 5 digital watches gets a total of 7,330. Find the selling price of each type of watch. Now let's take the selling price of analog watch be x rupees and that of digital watches be y rupees. Therefore, from first condition we get 11x plus 6y is equal to 4330. This is my equation number 1. By second condition we get 22x plus 5y is equal to 7330, which is my equation number 2. Now I have to equate any of the two coefficients, and therefore I equate coefficient of x by multiplying equation 1 by 2. I get 22x plus 12y is equal to 8660, which is my equation number 3. Now since my coefficient of x are equal with same signs, I will be subtracting these two equations. The constant in my equation number 3 is greater than the constant in equation 2. Therefore, I will be subtracting equation 2 from equation 3, which gives me 22x plus 12y is equal to 8660 minus 22x plus 5y is equal to 7330. Subtracting causes a change in sign, and 22x becomes minus 22x, 5y becomes minus 5y, and 7330 becomes minus 7330. This gives me 7y is equal to 1330, which gives me y is equal to 190. Substituting value of y is equal to 190 in equation 1, I get 11x plus 6 into 190 is equal to 4330. Therefore, 11x plus 1140 is equal to 4330. This gives me 11x is equal to 4330 minus 1140. This gives me 11x is equal to 3190, and solving this I get x is equal to 290. Therefore, the cost price of analog watch is rupees 290 and the cost price of digital watch is rupees 190.
The textbook questions which can be solved with this method are in the description below. Thank you for watching this video. Please like this video and help me in making videos better with your suggestions. Subscribe to my channel and share my videos with your friends. Bye.